Hello and welcome to another free code session. My name is Jason Bach and let's see if this actually works. I have a feeling I haven't edited the previous video, but I was probably not making a lot of sense because I was trying to do all this work in my head about where the bits are, and the value of X here is like the real true length with all the characters, and then the value of the bits are stored in groups of 8 bits and forward, and it just, yeah, I probably didn't make a lot of sense. But I think I've got this to the point where we can start testing. I would be shocked if this actually worked out of the gate. It'd be nice, but I would be shocked. I did remove some of these blocks here because these last 3 conditions do the exact same thing, which is div rem on X and 4. So it's going to be the same values and they don't change after that. These are just different. Again, this still looks a little weird to me, but I kind of like it. There's some, I'm just going to keep it in there. By the way, before I get into debugging and testing, or hopefully testing and no debugging, we'll see. But I did think this morning, as I was getting my cup of coffee, that could there be a way to not have to do this in a separate loop? I mentioned this before in previous videos. And I realized there could be. There's a trade-off here. So if you let that unsigned integer store 3 8-bit sets, not 4, but 3, then you could use one of the topmost 8 bits. Pick one, doesn't really matter. But pick one and use that to say, did you clear it out? And then that would just be a simple Boolean check on that bit to say, has it been set? And if it hasn't, then you clear it out. And the act of clearing it out would also set the flag to the other value. So that way, as you're going through the grid, you could say, oh, I have to actually look at the next value. I have to look at my current value and say, when I'm doing all 3 sets of bits, have I cleared it out? No, clear it out. And then if I need to move to another location because I'm wrapping over or back, then I would just quickly do that check on that set of bits to say, have they been cleared out? No, then do it. There's just no way to do it with the approach I have because I'm using all 32 bits. So yeah, it's a way to do it. The trade-off is that while this approach would still be a reduction from what I was doing before, and you don't have to allocate new arrays, you do now lose one set of 8 bits. So the grid size will be a little bit bigger than what I'm doing now. But you don't have to do that for loop iteration to clear them out. And so that becomes one of those problems or one of those questions of, what does the trade-off look like? Is it actually faster? You're going to allocate a little bit more memory, but is that okay? It's just, that becomes just one of those interesting problems of, if you're really trying to squeeze out as much as you can, are you trying to optimize for performance, like speed, or are you trying to optimize for reduction in memory allocation? The ideal would be for both, that you're always making both better. Sometimes you can't do that, and you have to make a trade-off as to which one you pick. But I'm going to say, I'm not going to do this really. Maybe later I'm going, well, maybe I'll just try that on the side. But that would require me to do something where I'm doing tests on the array manipulation itself and not have all the expedition stuff in there as well. Like, for example, I would write just some code that would be doing this in a loop and just do that, like, I don't know how many times, with a random set of locations of varying sizes of grids. But that would just be purely focused on this. But I want to get this done, and I have other things I need to do. I have a couple of presentations coming up for a conference that are new, and I need to get, I've been working and getting the material together, but I really need to sit down now and get some stuff produced and get it done. There's been an article I've been meaning to write, and I haven't done that yet. Twin Cities Code Camp. We are trying to get the planning off the ground and get things truly moving. And yeah, so hopefully I might have a little bit of a break in recording. It depends on my motivation and mood, but I do need to focus on a couple of other things for a little while. Okay. So you noticed there, I did the reformat because I noticed there was a space there, and I was reading on some thread in a C# group about formatting a code and, trying to make it so that the formatting is like virtualized and what you see is not really what the code is, but that's the way, you see it. And again, to me, I'm always like, just pick a style, go with it, make an editor config, have that enforce as many rules as you can, and auto format on save or whatever the case may be, and just flow, just go, whatever it is. I'm on projects right now where I work where they don't do this dot or the class name dot. That's a style I do all the time, but at the end of the day, as long as it's consistent, that's what matters. All right, let's run some tests. So get minimum minutes optimized, except we're going to do one grid. And again, I am completely under the impression that this is going to fail and we're going to have to debug. So let's see what this does. Yep, it failed. Although we're only off by 1. Which is kind of interesting. I mean, it got close. I'm kind of wondering. That makes me wonder. Let's just do an experiment here, okay? Let's do this. One grid. And then let's do optimized one grid. And let's make sure that is a startup. And now let's just run this. I won't let you see the answers. Okay, it's way off. It's not like it's an off by 1 thing here as well. It's way off. So whatever I'm doing in here is truly not correct. And that's unfortunate because I was really hoping that this would work correctly out of the gate. We do know that parse optimize one grid is correct. So there's basically 2 chunks. What we have to do here now is look at when we move these around, are they being moved around the correct way? This is also something we need to look at, though I'm almost positive this is doing exactly what it should do, which is clearing out the current bits and then shifting over to the new bits. Okay. And then these, we have to see, are they getting the right calculation to say that these 4 direction bits in a certain location are actually correct. So yeah, there's some work here to do. It would probably be better if I did this. Well, let's just, okay, I am in debug mode. Okay, so this may take a while. I'll go through this and maybe something immediately jumps out. Maybe it doesn't, but I am going to time box this and not spend so much time on a video just debugging. And, if it gets too far down a hole, I will do the rest of it off camera, and then I'll do a follow-up to talk about what I did to figure it out, because there's got to be something in here that's totally wrong. Okay, again, I am almost positive because we did a parse and we were parsing everything we thought was correct, and those should all be 0. And we are looking at the current ones. Yes. Okay. Let's see what we're doing wrong. Okay, so the virtual length should be 1, 2, 3, 4, 5, 6. But we really should only be storing 2. We have 2, and the x length is 6. So that's good. Okay. So now the first time we go through this, b limit should be 4, right? And it is. Okay. So now we're going to look at blizzards here, which this is going to be fun. I'd really like it to show as a... I wonder if I can do that here. Let's just try. Yeah, put in a watch here. We want to watch blizzards too. Which this isn't perfect. I would really like this to be formatted better, but it's something. Okay, it's as odd as that sounds. Now, this first value here, if we look at our, you can pull this down a little bit. Yeah. This first value should have, so we have 1, 2, 3, 4. My God, this is going to be text visualizer, XML. Yeah, I wish there was a binary visualizer. That would be nice, because I have to do this all by hand. See, this is much easier to read. Okay, so if we look at what this should store, it should store a right. See, I don't think that's actually correct. Even though I think our parse here, yeah, it's using, hold on. Our first row here is the same that we were doing essentially here, correct? And so the first value in the grid should have had a right, which is a right, a nothing, and then a left. So we should see the same thing here, but we're not. This is completely messed up. Why is that? Grids is 0 and 0. Blizzard is that. Wait, let's start over again. Because let me put in a test here quick, just to say parse optimize one grid first row. Okay, so we're just going to grab this. And then, come on. That should be 1, 2, 3, 4, 5, 6. So we should have an x length of 6, a grid length of 2. And this one, if we look at where those are stored, we should have a right, a nothing, and a left, which is a 1. And now we should have a up, which is that, and a left. An up. Oh, I changed that to here. I did that as a down. That's right. So up and a left. And the left is 1. So we should have this being a 0 and that being a 1. And the rest of this all should be zeros. Okay. So let's just run this. And that did pass. Okay, so maybe I don't know. Maybe it's too early in the morning for me to do this. But let's just keep going. So we know that that's parsing correctly. When I pulled it out of the grid, it didn't seem right. Maybe I'm not... No. Go into the debugger. What would that look like? Oh, that's great. That's just wonderful. Why? And the input... Oh, I'm a moron. I just spent 10 minutes. I forget that I reversed the thing. What we would really want to see is that first, which would be 0, 3. And I bet I now have as a side goal Yeah, and I think that's exactly what we see in our test. So that should be 10, 10, 10, 10, and then a 10, 10, and then zeros and then 1. Yeah. Side note 2. I should create a formatter to get the bits, all of them, and put separators in at every fourth location or defined by the user. I think that would be fabulous because, well, this is at least good they can do this. I want to do more. And maybe there's a way to do this already, but I would really like to do that. Maybe that's a spackle thing, but okay. So we are parsing this all correctly. Okay, I just was being stupid and I forgot that that's actually pulling out the top. Okay, so again, B limit should be 4 in this case. Okay, and what are we going to be doing here? We're taking right and we're going to move it over by no bits because we're trying to get the smallest 4. In this case, it should, because we just grab this down here and you notice that second bit is set. So I believe, oh, let's make sure what this is giving us here. That's still a 2. And so if we grab this whole thing here, it gives us a 0. Is that correct? Because I'm questioning that in my head. Yes, that's correct. And the reason why is if we come back up here, we are going left. Yeah. And that's a 1. It's not a 2. Okay, so that is correct. But left is 1. We should be going left. Okay, now here's the thing. We should be going to a, because we are technically still on that first one, and we need to go left. And so this is where we now need to actually cycle back to the first element, but since this is 6, it has to be the second set of 8 bits, right? So what do we get out of this? Q is 1, and the remainder should be 1. This, I think, is correct, because we need to get into the x equals 1 position, which is what we're going to do here. And we need to shift over 1 set. And that's what we're going to do here. Okay. And so we're going to OR that in with blizzard direction left in the new position. Okay. So if I do this, and I apologize that this is kind of tedium. Okay, I get that. But we're going to do 0, 0, and then I'm just going to do 1, 2, 3, 4 because I need this in my head. Okay. So what we are expecting is left. We would expect this bit to be flipped. Actually, no, we would expect this bit to be flipped because that's the one all the way to the right. That's the 6th X. I think it did. Yeah. So now in the new position, that's where it's going to go. Okay. And so that did work. Yeah, I just panicked for a second. I'm like, could something else push to the right? But you'll never have that happen. You can't have, like, at one location 2 blizzards that have the same direction. The maximum that can be at a location is 4 of one of, and you can only have of one type each. So never mind. I'm just overanalyzing the problem. So I think that's correct as well. And what I want to do now is say, I want to see when the length is greater than or equal to this, and see when b limit is less than the length. Because if it's if that's greater than that, we just go 4 times. Otherwise, we need to do whatever that was minus length, and that should be 1, 2, 3, or 1, 2, or 3. Yes, because if it was 4, yeah, okay. Again, I'm talking numbers out loud, and it doesn't make any sense. We don't have to worry about doing a quotient and remainder for these because we're just going either up or down. And so I don't think that's where the problem would be. Though I would really like to make sure that these are correct. And we've done this now. What's funny is that there is a problem somewhere in this code. It's either here or it's down here somewhere. And when I finally see it, I'm going to be like, oh, you know what I mean? I'm going to be like, ah, and there's going to be a lot of screaming. So I'm going to stop here for recording because I need to do some very technical debugging, meaning I got to be really close in watching what I'm doing. And this may take minutes or hours to figure out where the problem is. But once I do, I'm going to once I figure out what the problem is and I've confirmed that I'm getting the same values, then all I have to do is run the performance test. So what I'm going to do is I'm going to stop this chunk, but I'm going to end this video with me having the solution. And I may have a different shirt on. The lighting may look a little different because it may be another day for all I know. But that's how I'm going to end this video. So I will come back with everything figured out. Okay, I did solve it. I did finally figure out what the problem was, and it was literally one thing. And I have a different shirt on because I did my self-defense lesson today, and this was what I was wearing when I exercised doing self-defense. So I have a different shirt on, but it's the same day. Basically spent all afternoon looking at this. It wasn't frustrating. It's just I had to break it down, use the things that I found out with the previous optimization so I could see are the bits working. Moving the blizzards around in the grid, that was fine. That was not the problem. So I narrowed it down to something with the expeditions must be off. And so I started just going through, because to compare those would have been a little bit harder, I think. But I just went through the code again a couple times and making sure that it was right. This was a problem in that I think I was using the max X, but like I said, we never get into pruning size. So that to me really wasn't it. It was this. This should have been equals to, or I'm sorry, it should have been this. It was equals to, and it should have been this, because this is saying that where you currently are has a blizzard in it. And so you can't be, this is not a valid path to go. So you can't be here anymore. And that's what the other code was doing. So did this, ran tests, and came up with the same exact values as the other approaches. So this is the way to do it. So what do the results look like? A little surprising. So you'll see here that the time between what I was doing with the optimized flag enumeration bit values compared to what I'm doing with just one grid, there really is not that big of a difference. If anything, maybe it's slightly slower. And that surprised me a little bit. The thing I thought of is maybe because I'm doing all these div rem calculations, that those are a little slow to figure out where, and moving all the bits around to do bit masks. You know, maybe if I didn't do those, this is where now I would be getting into the profiling of this to see where the hotspots are in my approach, because I'm not really sure at this point why I expected it to be a little bit faster and it wasn't. So, but hey, you learn. It could also be that I'm iterating through that grid again to move all the bits over and can't, you know, zero out some of them. And maybe if I did that approach I talked about before with having a 32-bit value take 3 values and use a bit to say whether it's been reset or not, and then I don't have to do that. But then that's time I have to spend to say if I have to move over to another one, clear it out first before I, or do that reset before I do any calculations. It does take some less memory. You can see that the allocated went from 24.2 megabytes to 20.9 megabytes. Again, this is a little bit less than what I thought, but it did improve, so that was good. I'm guessing that most of the allocations come in when you create an expedition, and the arrays and everything or the lists I have to make, like if you go into here, whenever we're adding a new expedition, that's a part of it. We create an expedition with an add range here. We add all the new expeditions in, and then we create a new hash set. One thing to try is just to have this always be up here a hash set of expeditions, so that when you add one in, you are automatically making sure. Now that's going to add some time in, because to do a hash set, you have to make sure that you have something unique. So when you're adding it in, that would cause a little bit of overhead that way. But then we are also eliminating resetting the array to a new hash set with all the expeditions in it. We wouldn't have to do that anymore. So that might also be something to optimize out. But at the end of the day, this has been fun. I'm really going to say stop. I may do some more things, like as I'm doing this, I'm looking at that hash set thing and maybe just trying one more where I don't do a hash or a constant list and rehashing and things like that, and just see what that does with the memory. But this has been fun, as frustrating as it was this afternoon a little bit. Just it came down to one thing, but that was finally fixed, and now I'm done with this. And again, it's just been fun to learn it and kind of push things and go, where can I make these optimizations? And then, as I just explained, the optimization I didn't help as much with performance as I thought it would. I thought it would actually do a little bit better. But this is an illustration of why you do tests and why you do those kinds of things to get data to see, does it actually come out the way you think it should? There's been so many times in my career where I've seen people say, "Oh, do this, it'll be faster." It's not that they're wrong, but are you sure? And there are some things I could say, if you did it this way, and I'm suggesting you do it this way, do it. Like, I know that's going to be faster. But there are some other times where you do need, more often than not, you really do need to just do some type of performance tests and profiling to see, are we addressing what's really a hotspot, and are we making things better? Intuition doesn't cut it. It helps, but that's not a proof. Data is that thing that you need to not necessarily prove it either, but to give a lot more weight to an idea, an argument, an assessment. So this, again, is a good illustration of that. At least it is to me. So thank you all for watching. Leave comments and questions below. See you in the next episode.